All right, here's how you're going to tackle this next algebraic task that we have in trigonometry. Often goes by the name of verifying trig identities. Might seem a little strange at first, but after a bit, I think you'll find them to be quite enjoyable. So I think I might just jump into an example and show you by way of example how this works. But you can also, this is a lot like proof. These are basically proofs, although you don't have to worry about the whole two-column thing. Each step doesn't have to be painstakingly justified. It's algebra, and so long as you're making valid algebraic steps, you should be fine. The rules, actually there's really only one rule. I mean, you got to do valid algebraic steps, but can't cross the line. Don't cross the line. What? All right, let me show you what I mean by that. It's pretty simple. We're not solving equations here. When you go to verify a trig identity, you're given something that you're told is true. For example, here's a trig identity. Cosine of t over the secant of t times the sine of t is equal to the cosecant. They can get a little wacky. This one's a little wacky. I didn't want you to start you out on one that's too simple. We're told that this is a trigonometric identity, which means that this is always true. We're not trying to solve this equation. That's not the assignment here. If you want to solve it, by all means, go ahead and solve it. Actually, that would be kind of a pretty good exercise. Solve if you must. But that's, whoops, that went off the page there. Solve if you must. What we're trying to do is show that this left-hand side is equal to the right-hand side. So what I like to do is draw a little line down the middle. Hence the rule, don't cross the line. All we're doing, same thing we were doing yesterday, is we're going to simplify the left-hand side independently of the right-hand side until it did the same. And remember, our guiding question isn't what am I supposed to do, it's what can I do. I'm just going to rip into this thing. You can make some different decisions if you like, but I'll just kind of show you how this might look. Cosine t over secant, which is 1 over cosine of t, times sine, which is sine of t over 1. Then I'm going to think, what should I do? I'm going to use that trick where you multiply the top and bottom by cosine. Cosine of t on the top, cosine of t on the bottom. So on the top I get cosine squared of t, and on the bottom the cosines cancel, and I get sine of t. All right. And when you get to a point where you're like, well, I tried things that I thought seemed pretty obvious, and I'm not really sure where to go next. The way these work is then you can jump over to the other side and say, okay, well, what can I do on the other side? Moving over, in your book you'll use LHS and RHS, left-hand side, right-hand side, if you're reading some of these in the book. Cosecant is 1 over the sine of t, and this is sine of t over 1. Alright, well I can try to add the like fractions. The like fractions? What? I need a common denominator to add the fractions. So this is going to be sine of t. Sine of t, so we're going to get 1 minus sine squared of t over sine of t. Okay, well that 1 minus sine, hopefully by now that 1 minus sine squared is having you go look for the list. 1 minus sine squared becomes cosine squared of t over sine of t. And then, if you're paying attention, you'll notice, hey, That's the same thing I had over here. And at that point, you're done. At any point along here where you're like, this is equal to this, you're done. And you can signify that by drawing a little arrow, indicating that those are the same, and writing yay. That's how I'll know you're done. So, a little weird. Give them a whirl. Left-hand side, right-hand side. Don't cross the line. Simplify the two sides separately until they're the same. You can work entirely on the left-hand side until it equals the right-hand side. You can work entirely on the right-hand side until it equals the left-hand side, or work them both until they're the same thing. They don't have to be what you started with. Okay? Your homework is the following. I'll also put this on the forecast on page 533, number 25 to 65 by 5s, meaning 25, 30, 35, 40, 45, 50, 55, 60. Okay?
I only
How about
do that
them?
because she doesn't really
Have fun.
care about